Okay. Hey guys, Phani Koganti. I'm going to talk about intent-based automations with our Fabric Services System today. Today application architectures have been the primary drivers for some of these modern data centers. And at the end of the day, I strongly believe that these modern data centers are in the business of serving these applications. And the network is just a citizen that needs to participate and do its job. Now, the application architectures have come a long way and they have stabilized on a cloud native microservice. And the data layer below that, which is where a per type business logic a microservice uses a different type of database. And more importantly, all these data layers or the data types also have been highly distributed and becoming cloud native. And the lowest layer, which falls under the infra, is the storage and is very critical. The storage layer is also aligning towards a software defined and a distributed storage. The point I'm trying to make here is that the data centers have been evolving and there's drastic changes. There is a lot of dynamism, there is a lot of distribution, and the network as a citizen needs to play its role, where the network needs to be multi-tenant and need to provide that service level connectivity across data centers as well. Now, in our mind, the modern data center fabric, what are the building blocks here? What we believe that to summarize, the key building blocks are that, you need to provide various tools that take care of your day zero design, day one automations, and day two plus observability and various other change managements. Among all these tools, for us to deliver automations at scale, technically there's only one way to deliver automations at scale. It's via an intent-based approach, and we take an abstract intent approach, and I'll go into the details of that. And obviously, apart from just delivering automations, you got to try to adopt some standard designs that are very open, and there's wide skill set in the market, like standard class-based design, standard BGP-based IP fabrics. And you got to drive that simplicity in these data centers so that you can have that cookie cutter aspects, and these simplicity will contribute to the higher scale as you build larger scale networks. But also on your day two plus operations, the simpler the day zero design is, the simpler are your day two plus operations are going to be. Now, when you combine all these abstract intent-based automations and you kind of combine it with some kind of innovative network virtualizations, I'm not going to go into all the details, but at the level of doing a logical switch, a layer two or at a layer three, some kind of a distributed anycast gateway, combining that with various overlay implementations, it's going to really simplify the life of the operator. Now, while these application workloads, these can drive continuous changes in these data centers, we strongly believe that the operator needs to be enabled to handle risk of a change in a very confident way. So we believe that the modern data center really needs a true emulation of your real network. We call that as our digital sandbox, and I'll go into the details of it. We believe that as you allow the operator to make changes on a digital twin, he will be able to more confidently make changes before applying to the production network. Now, on day two plus, following that intent, which is the desired state, you have to monitor all kinds of metrics, and you got to ensure that various metrics that you collect at the end of the day are matching to the desired state that the operator wanted. And if there are any deviations, we want to enable the operator to make a few decisions so that he can easily make sure the desired state is maintained. Now, when it comes to the telemetry and observability part of the aspects, it's the same thing. You got to focus not just on throwing raw telemetry data on the screen for the operator, but rather focus on insights that will enable that operator to quickly debug and get to the root cause. Or let's say he's trying to onboard a new application workloads, he can actually do a more accurate planning, capacity planning, and make a good decision. And also on that day two plus side of things, as the randomization of the data that you collect increases, this is just simple technical stuff, but the truth is, as the randomization increases, how much ever data you throw at the operator, he's not going to consume a huge amount of data. So you got to apply modern techniques like ML based, and conceptually I call that as a software operator. So you got to complement that human operator by helping him by a software-based or a ML-based operator that analyzes the data on the random data that he gets, and then help the human operator. I mean, eventually you will see a pure ML-based, some kind of a highly cruise control networking. But we strongly believe that the next thing that needs to happen is a software operator helping a human operator. And at this stage, I'm basically trying to make my case towards, look, we need to manage the full life cycle of a fabric all the way from day zero. And we do that apart from, we also take care of the day zero design. That's where the operator actually expresses his intent. And also we complement that with a unique capability of a digital twin, which we call it as digital sandbox, where you can even try out all combinations of your day zero designs, but also play out all kinds of config changes or even upgrades. And that really mitigates the risk or reduces dependency on hardware, and it really want to do the full lifecycle management. And that's what we're trying to summarize here. And it'll become more clear when we get to the actual demo. And hopefully you'll have more questions at that time. So I want to give you a peek into how we have architected our automation and operations platform. Fabric services, we adopt a modern event-driven microservices architecture that rides on a Kubernetes-based framework. And architecturally, this implementation is divided into 4 key pillars that you see on the screen over here. And all of these pillars have basically a bunch of microservices grouped together, but functionally, we did want to architect it such a way that we focus on 4 key pillars here. And all these microservices, at the end of the day, they expose a open API compliant REST endpoints that a northbound user can use and automate further. And these northbound REST endpoints will be used to integrate into the surrounding ecosystems like compute, storage, or any other in-house operational tools using our loosely coupled Kubernetes framework. So we really want to bank on the wide availability of the Kubernetes skills, apart from ourselves gaining from the overall microservices and a Kubernetes native implementation. As I indicated, we obviously wanted to build an intent-based platform. So I wanted to give you a simple picture that gives you the big picture that explains our intent framework. And in our intent-based framework, to build the underlay, we would provide a modular intent. It's not just abstract intent, but it's a very modular that you can build a bunch of leaf spine fabrics. And then, you could build another layer for interconnecting these fabrics, and we call that as a backbone fabric. And once these fabrics are built to onboard an application, it could be a monolithic app or a highly distributed application, the applications basically need a layer 2 or layer 3 connectivity, right? We express all those connectivity requirements in something called workload EVPN intent. And once these connectivity aspects are taken care, we also want to do a very tight integration with the surrounding compute. That's where all the applications are running. And typically these compute clusters are either using like a VMware ecosystem or a OpenStack or a Kubernetes ecosystem. And we have implementations to tightly integrate with these ecosystems and try to learn what's going on. Like, for example, on the VMware side, and figure out as the VMs come and go or as the containers come and go, we would automatically do the needful on the network side. See, you guys are used to, in networking, we call it as a life of a packet. So I would like to walk you guys through something I call as life of a fabric. Here, I'll just focus on this vertical line over here, and I'll go into these horizontal details as I go to the real product and try to demonstrate each of it. So on this side, typically, let's say you're a data center operator. You'll first figure out, hey, look, I have an operational organization. I'll figure out my users, their roles, and the kind of privileges they have, and all those aspects. I'm not going to show the user management stuff on the real product. These are the usual suspects. You'll find a very sophisticated RBAC control and all those things. But at the end of the day, we also understand that not all privileges are expressed on a given network management product. You would like to tap into your central directory service, so we integrate with an external LDAP as well. So the next step is you want to create a region. The concept of region on our side is very similar to your public cloud side. Where let's say you're familiar with the Amazon AWS regions. It's exactly the same. It's just a wrapper intent that allows us to quickly group multiple infrastructures that you're building and group them into a region. And as you can imagine, you will, for a very large customer, you would deploy across multiple regions and so on. So let's look at the real product and see what I mean by that region. So this is the landing page when you basically log into our automation platform. And when I go into my regions, I have, in the interest of time, I've pre-created some of these. The kind of details you configure at a regional level is you obviously give a name and description, but look, at the end of the day, when I'm building the infrastructure, a bunch of routers, I want to user to give me an idea about, hey, look, what are the starting IP addresses that I need to use for automatically assigning router IDs. Similarly, I'm going to build a standard BGP-based IP fabric. I do not want to conflict with other private ASIN numbers that are potentially used in the network. So can you let me know what kind of private ASIN range I can use? And similarly, as I interconnect multiple switches, I'm going to automatically enable BGP and do some routing on it. So for that, I need to plumb the IP interfaces. And we're going to do this regular /31 style interfaces. So can you give me an IP CIDR block that I can use to auto allocate and fit into the overall zero touch as well? And we also are a full-fledged ZTP server. We are a full-fledged DHCP server, image server, all the needs of a typical zero touch. Our FSS is a full-fledged one, meaning you just configure even for the management CIDR what you need, and that's it. There is no need for any external DHCP or external involvement at all. And obviously, if you're not directly connected to the layer 2 segment, you can even deploy a DHCP relay. And basically, at the end of the day, once the DHCP packet comes to our server, we take care of the standard ZTP, and it's a 100% zero touch.
I got a question for you real quick on that.
Sure.
So can you guys do V6 only on the underlay, V6 only on the overlay? Is that a set of capabilities that exists in the product? Because
it does.
And then do you require all global unicast, or can you do it as an underlay fabric as link local? What's the configuration?
So Ed, let me quickly refine my answer there. The platform is capable. We have done most of it, but for the V6 underlay, it is a roadmap item. As of now, it's probably going to come sometime at the end of the year, but the capability exists. But first things first, we are optimizing for V4.
Is it dual stacking the underlay with just the fabric, with the actual fabric build being done on the V4 side, or does it V4 only and then V6 as an overlay, or dual stack as an overlay?
Yeah, V4 as underlay and dual stack on the overlay. Basically, as you can imagine, the VXLAN Vita needs to do the V6 part, right? So all the next-gen hardwares like Trident 3s and all those, they do support that. And the capability exists. It's already on track and on the train.
Yeah.
And
so
your second question about multicast versus unicast, all the bumped replication, we initially do only ingress replication, which is based on unicast. We don't have any PIM-based replication at this time. So that was about regions, right? So I've configured the ZTP related stuff, given all the relevant IPAMs and given me relevant all the BGP and numbers. Now, next thing is I would like to create fabrics. Here, we take a very abstract intent approach. I just want the user to tell me high level information. I don't need him to be a BGP expert or any general IP fabric expert. Doesn't mean when we really on the operational side, we give very granular data, but for provisioning side, we don't want to assume and make the life of the operator complex so that he has to provision like 100 attributes. So we just take some high-level abstract information, look how many leaves and what is the type of the leaf platform and the number of spines in the spine platform, and that's good enough for us to deliver a standard class topology and a standard BGP-based IP fabric. So let me show you at this stage how I would just create a fabric, and we call it as a fabric instance. I'll quickly show you creation of a fabric. As you click on the create button, we'll give you some templates. These templates help you simplify your overall network design, but also they go through rigorous QA testing in our labs. So you will inherit the stability that we achieve in our labs if you use these, but doesn't mean that we will literally hard code you. This is just a starting point. For example, I'm choosing a template called flexible leaves fine. This gives me more flexibility and all kinds of things can be modified. And when I choose that, it basically asks me a few obvious things like give me a name and some kind of a description. And I got to choose which region I'm building this infrastructure in. For example, I had pre-created this region called EBC2. I select that. And then I also have to give him, hey, look, what is the software image I would like to use on the switch? That way, I'll ensure I'll use that image during my ZTP process and build the fabric automatically. And as I was indicating, we have the differentiating feature of doing a true digital twin. So we actually have options to create a real fabric, meaning I'm operating with real hardware versus, hey, look, I'm trying to play around. I want to just play it on the sandbox. It's just a type variable for us. We do not differentiate or try to have a major difference between the two types of fabrics. We truly believe in that digital twin concept. So we will try to keep it exactly the same. So from our FSS point of view, that if I'm creating a real versus a sandbox, you'll find zero differences.
So, hey, Phani, this is Jeremy. I got a question about the underlying mechanism that this application is using to manage the devices.
Yeah.
So, in the previous slide, we saw that the operating system had, a different array of management, like GNMI or, those types of protocols. How is this application managing the device?
It's using GNMI as well, Jeremy.
And is there a specific app for FSS that's running on the device?
No, Jeremy. Whatever the standard GNMI interface exposed by our SR Linux, we consume that standard interface only. We are nothing special. As Bruce was explaining, it's so flexible, and we do not want to do anything proprietary. Meaning, even between our automation platform and SR Linux, if I can do it, you guys can do it as well.
Okay, so the feature functionality is defined essentially by what is allowed by GNMI.
Yes, and we do a good job of every feature that is exposed in CLI has to be exposed through GNMI, every knob as well.
I've got a question here about the Fabric Services System. Every time I see a GUI, based application like this, I have to wonder, is there an API that I can use to actually automate some of this stuff with my own tooling, where I would talk to Fabric Services System and use the.
Yeah, that's a good question, Chris. Absolutely. We do not want actually people to rely on API. As you can imagine, these larger infrastructures need a lot of things to be done, right? So we expose a open API compliant REST endpoints, and I'll actually show you exercising those APIs and do a few automations in front of you guys. Absolutely, all the integrations we do, for example, with VMware, and we are aggressively driving towards an end-to-end 5G cloud within Nokia, which is a very cloud native, and all those integrations, everything is all API based. GUI doesn't come into the picture at all. Just to highlight the capabilities for this demo, it's easier for me to show it on the GUI, but absolutely,
And does that API have feature parity with the GUI as well, or do the features lag sometimes, or is that one-to-one?
No, it'll be the other way. The APIs will be more richer.
Beautiful. One last question here, back on the topic of IPv6. So it sounds like, IPv6 is not supported, an underlay of Fabric. It sounds like maybe it's an ASIC limitation. I understand that. But for communications between the Fabric Services System and the network devices, can that operate in a V6 only environment? Or does it rely on V4?
There's no strict restrictions as such architecturally, Chris, based on the customer use cases. Absolutely, if they need V6 only, not a dual stack, absolutely.
Thank you.
So guys, I just gave a few attributes as I was indicating, and let's say the spine type, I have 2 spines here, and the leaf type is, I'm not going to change that. Let me use the default one, but let me try to build for, let's say, 8 nodes, meaning for 4 racks, I just specify that kind of a high level information, do a save, but hit a save on it, and we create a version 1.0. All these intents are high version controlled. As you make changes, we absolutely in the backend do a version control and track the differences that are happening. Now that I have a version 1, I just click on this generate fabric, and this is going to actually generate the detailed topology using standard class, but also it is going to generate the detailed configuration on a per node basis. For example, I have 2 spines and 8 of these leaves, right? I can just go to one of the spine and just say that, or any of the switches, and say inspect configuration. I be able to check, this is like a pre-check. I could look at all the config that was generated, and the config that I'm showing you guys here, it's syntactically exactly the same config that SR Linux expects. If you just do a cut and paste, copy this config and paste it on one of the box, it's going to just work. So, and you can inspect all the configuration of all the nodes before you actually, so keep in mind, I haven't deployed it. Before even you deploy, you can inspect a lot of things. And for example, you can look at some of the details of what exact is the node type and what is its various other attributes. And sometimes, you can actually click on one of the links. That's fine. I'll show it in a different fabric that I have. But the point is, here it is as simple as that. We take some abstract input and we generate the fabric. And what I've done is I've pre-created 3 fabrics that are very similar to what I showed you. In Fab 1, I have 3 leaves and 2 spines. And I have Fab 2, which has again 3 leaves and 2 spines. And as I was indicating in our intent framework, we have something called backbone fabric that allows us to interconnect a bunch of leaf spine fabrics. So I've created a backbone fabric with 2 boxes, and each of these boxes is going to serve as an interconnect between these 2. And the information button that I was explaining, I have all these details, but also if I click on one of the link over here, I would also get detailed information. For example, this line is actually 4 links. I would get detailed information about what switches are involved and what are the specific ports and the specific /31 subnets that I have assigned for this to build the IP fabric here. So this is my infrastructure over here. So I have built my fabric. Now, let's say I want to do all the stuff that I've showed you on a digital sandbox. The concept of our digital sandbox is we take the SRL code, we containerize it, and we use Kubernetes tools to actually build a fabric out of it. N number of these containerized SRLs come together and they build a fabric out of it. Apart from that, we also emulate endpoints like the servers, and we also generate traffic. And more importantly, we are capable of emulating a BGP speaker, meaning, let's say you don't want to emulate the whole data center network. Let's say the device under test is only Fabric 1. The rest of the network can be represented by a BGP speaker, and he can inject all the prefixes so that the device under test as Fabric 1 can be done. We also have a very unique feature where this whole virtual or this sandbox can break out into the physical world, and the regular physical ports will come out, and they can be interconnected to any third-party routers or a storage hypervisor or like firewall, whatever is that appliance. And you can test your interop, and you can qualify all kinds of things without even relying on physical hardware or waiting for the physical hardware. Now, so for that part of it, I just had already a pre-created stuff. As I was indicating, guys, the only difference you will find is the type happens to be digital sandbox. That's it. You will not find any difference in provisioning. Everything will be the same. And also, the only subtle differences you will see is that you'll have an extra status describing, how is the sandbox doing, if there are any potential errors that I need to display to the user. But everything else, every other provisioning model is exactly the same when you do it for real versus
Hey, Phani? This is Jeremy. Can you
Yes, Jeremy.
can you take this picture as it stands and say, well, now I want to add another spine to it, for whatever reason, say I want to do more capacity and I just want to add one more spine to this and have the system automatically lay out the connections to each of the leaves. So it just kind of picks the next available uplink port, however that's designated in the product. Can the system do that kind of what I like to think of as AutoCAD kind of layout?
Yes, Jeremy. So we do support adding of additional leaves or adding of additional spines. And as you can imagine, when you add additional spines, sometimes rewiring will be needed. So we do alert the customer about, hey, look, this could be disruptive operation, but if that is what he wants, absolutely, we will redo the topology and we will recommend what is the right topology, and sometimes even take inputs from the user. So at this stage, what happens is that, look, you have built your underlay infrastructure and you want to figure out how to connect the compute to the actual fabric. You might want to do a multi-homing. The MH here means multi-homing lag. Every compute would like to have a redundant model, so you want to connect it to a pair of switches. So over here, I have pre-created some of these to show you guys. What happens is, in a given fabric, we basically show all the list of links that are there between the switches. The whole topology is shown over here. And then this whole thing can be even exported to a CSV or an Excel sheet. Similarly, we have an inventory, and we also have a list of edge interfaces, meaning these are the links that we use to connect towards the endpoints, meaning the computes. I've pre-created a lag over here. It's as simple as, hey, look, you want a multi-home lag, pick the ports. Let's say here I picked port 1/4 on leaf 1 and 1/4 on leaf 2. That is it. You just enable the multi-home knob over here and we'll take care of all the magic. And internally also, we implement multi-homing using standard EVPN. You will not find any proprietary things, meaning no proprietary control or data plane protocol will be found here. And I call that as an open on wire, but these are all the edge interfaces on which the computes will get connected to. And once these infrastructure, the intent-based fabrics are deployed, we actually have a very closed loop of monitoring what's going on, and we make sure if there are any deviations to the desired state, we alert the customer, and we also give a little bit of a flexibility for the operator to. This is a snapshot of how we would display, hey, look, I see a intent deviation. For a good reason, the customer might have logged into the box and made a few changes on the box at a CLI level, but we will continuously track, and instantaneously we will show the alarm saying that, look, something deviated. Unlike other systems, we have a unique capability to accept or reject that change. Sometimes operators do it for a good reason, and you cannot put a strict enforcement that I only do top-down approach where everything has to go from your intent-based automation platform. Rather, we allow you to say, accept what you're seeing as a deviation, or you could reject it. So in this example of this screenshot, I had done an admin down on a port. So he'll tell me what was the intended value was enabled, but the node sees the admin state to be disabled for 2 ports. And if you reject it, automatically the switch, the FSS will bring back the fabric to the desired state. But for a good reason, you had intentionally disabled it, you could accept it as well.
And one quick question, sorry. So with all of the templates that you guys have and understanding that you guys have to go through and validate these, how much flexibility do you give to the users to actually either define their own or to modify the defaults? Because not every environment is going to fit the standard template.
That's correct, Carl. And we were conscious about it from day one. Although I showed you that abstract intent, what happens is that we actually provide a lot of, let me show you. So what I call it as subprofiles, meaning, I group all the knobs into various layers of configurations. And this is just a growing list, Carl. And for example, if I want to have a different behavior for how the management traffic is prioritized or how it is treated, or what kind of additional security rules I want, or what kind of fabric level QoS I want, or even how I'm building the underlay, I would like to have some opinions here. So we group them into subprofiles. The template only allows you to build the 90% of it. And let's say you need to customize every knob also. At an API level, we do have that. And we want to grow based on the feedback coming from customers, what kind of flexibility they need. It's going to be a balance, for you to keep the design simple and try to achieve a cut and paste cookie cutter style and simplify the life of the operator. We do believe that some level of config needs to be auto-generated, and doesn't mean you have to be rigid there. And we do incorporate flexibility. Now the level of flexibility, it's going to be keep on increasing based on real use cases, rather than, let's say, open the doors and ask the customer to configure all the 100 knobs. And here, as you are done with the infrastructure, you are now ready to onboard application workloads. These could be typical monolithic or distributed application workloads, but we try to model the service level connectivity like a cloud style. You have a region that I explained, and within that region, you can create a macro segmentation like a layer 3 domain. You have a unique routing instance. And within that, you can create one or more subnets. Each of those subnets is a broadcast domain, so it is a MAC VRF. And then computes come and attach to each of these subnets. And these computes could be bare metals, VMs, or containers, but they come and attach, and there's no difference for us. We don't care, and the overall architecture simplifies it for all kinds of virtualization. And across these subnets, it's an integrated routing and bridging, meaning if you need a MAC level reachability within the broadcast domain, you have that as part of the MAC VRF, but you're crossing the MAC VRF boundary and you need to talk to somebody across the subnet, you do through by an integrated routing and bridging. That's the simple model that if you can register in your brain. And when I come to the left side, all these service level connectivity, we absolutely follow standard based. I call it as an open on wire, no proprietariness, even for delivering a multi-home lag, zero proprietariness. And we even take it to the next level of delivering it across not just 2 nodes, but more than 4 nodes. And in future, we'll increase it to a larger number as well. Now for the layer 2, layer 3 connectivity, if you guys are familiar with the EVPN, we do support all the flavors, asymmetric and symmetric IRB part of it, or the IFL and interface full and interfaceless, all those combinations, but we stick to the standards. The key point here is all these EVPN aspects, not all operators need to understand. The way you will see our provisioning model will ensure that although you're not an EVPN expert, you will get the EVPN provisioning 100% accurate. That is the idea behind our abstract intent. And we'll make you focus on, hey, look, you're onboarding an application workload. Tell me what downlinks are you going to use on the fabric and connect these application workloads. And these application workloads are not going to be restricted by a fabric boundary. You are going to allow him to span across 1 fabric, 2 fabrics, or even across data centers. For the service level connectivity, there is no limit. So let me go and quickly show you guys on the real product how the overall workload in VPNs look like. I'm going to create a quick thing in front of you guys. I have created a few EVPNs. I'll explain you very quickly the overall provisioning model. And it's so simple that I don't think you guys will have any confusion, but you can pause me and ask questions. And if there are questions, I can actually create a whole workload in front of you. So what happens is that similar to what I showed on the fabric, we ask for a name and few attributes. But in addition to that, we also ask you to tell me for this workload, what all fabrics will it be using, or what all fabrics will this application workload be hanging off. I have selected only Fab 1, but I could have selected all 3 also. That is one additional thing that this workload intent asks for. And then once I have created that workload, we have a concept within that workload, as I was showing, you can have 1 or more subnets. And within a subnet, you will have 1 or more subinterfaces, meaning those attachments on how the compute comes and attaches into the network. So it's a simple hierarchical provisioning model. I create a routing domain and I create one or more subnets or broadcast domains. And within a subnet and a broadcast domain, I provide various attachment points, which we call as subinterfaces. So you guys were asking about APIs, right? So let me, for my data plane demo that I was talking about, I basically have, I wanted to create a layer 2 EVPN for you guys through APIs. I have a simple script that basically calls my REST endpoints. Let me go to the EVPNs. I have only, I'm going to quickly create one more. It's basically calling my northbound REST endpoints, guys. We can even share open source some of these examples, nothing closed about it. So I have the fourth EVPN that I've created over here. It's a layer 2 EVPN that is spanning, hanging off of Fabric 1. And within this Fabric 1, I basically have a CE device 1 that is hanging off leaf 1 and CE device 2 hanging off leaf 2. So what I'm going to do is, this is a layer 2 EVPN. It's a MAC VRF. Right now, the EVPN is not created or deployed. So if I do a ping, it's going to fail. So let me start that ping. So I just quickly did an IP address show. This CE device has multiple interfaces, but this is the interface of interest. This guy is 1.2. And the other CE device, he's CE2, the other device is 1.1. I'm going to hit start a ping, and you'll see this is not going through. And at this stage, I have the relevant subnets that I've already created and all that, but I basically need to generate the workload here, meaning the relevant config that I need to push to the fabric. Let me generate that. If you see the bottom bar over here, it has finished generating the configuration. You see how quick it was. And again, even here, you can inspect the configuration. The config needed for this workload is spanning across 3 leaves. So we will show you only the incremental config that is relevant to this tenant or this EVPN, or else, it's going to overwhelm the operator as well. So you can inspect the config, and it's as simple as I want to deploy this config or this EVPN to the real fabric. I just add it to my deployment pipeline. We have a concept of deployment pipeline, which is per region. This is basically, to accommodate multi-user or multi-session. Let's say you have 10 operators who are creating 100 workloads, meaning 10, let's say 10 each, and all of them are pushing it and scheduling it. You got to put a structure around it. If multiple configs go and try to configure the same infrastructure, you will get into so many conflicts and you will be asking for trouble. So we absolutely put a structure around it. It's a first in, first out. We basically serialize things, although there are multiple users scheduling things that needs to be deployed. And also we got feedback from customers that, look, the operator who is actually scheduling the provisioning, the source of the user, need not be the guy who has a privilege to actually deploy it on the infrastructure. Some of these operators or these data center customers want to actually review and approve. So here I have enqueued it. My line item is on the top. I'm a super admin. I'm logged in as a super admin, so I have the privileges. So I just hit on the deploy.
Phani, I got a quick question for you.
Yeah.
What if I come from a different approach? Say I've got a tenant that says that their MAC address is not being propagated across the fabric. Can I go in and select which route type or do some sort of a troubleshooting with this tool, or how does that work?
Absolutely, Kim. I'm just showing you the deployment or the automation side of it. We'll be in a business of continuously monitoring not just the config state, but the operational state. And the operational state doesn't limit itself to, let's say, a link or node or any other modules. We'll be actually monitoring the RIB. When I say RIB, both for the IP as well as the MAC. In the EVPN stuff, MACs are also, they are the MAC RIB, right? So we will be having visibility into all of that, and any deviations we will be able to alert. And if you need to block, or even if you want to insert any static entries, those also will be possible. I have 3 more types. So I basically have other types of intent EVPNs where there is a layer 3 only EVPN. In this case, what happens is that you basically create a subnet and say that the type is routed, meaning I do not have a broadcast requirement at all, meaning I don't need MAC VRFs. In this scenario, what happens is that I don't configure an IP address per subnet, but rather, each of the sub interfaces will have an IP address because they are directly talking routing with the endpoint, or probably they're interfacing with an external router. And the other type is you could have a regular IRB interface with a lag as well. Now, in case of IRB, all these subnets will be a bridge, although they're capable of routing. What it means is that I'm capable of bridging as well. Doesn't mean I'm not capable of routing. I'm also capable of routing. And within a subnet, you will see that I can actually have the attachment points be regular lags as well. And these could be multi-home lags as well. Hey, Tom, let's stop here. If you look at my overall slides, guys, the point here is I'd created the workloads, and let's say at day 100 or so, Nokia gives you a new software image for the switches. You can perform maintenance on it. We have an intent-based approach that allows you to group a bunch of switches and perform a bulk upgrades in a very, very flexible way. And it's something unique to our implementation. As we worked with one of the large partners, we were able to do a sophisticated drain policies that will allow to drain the traffic before you upgrade. And all of those, it's a 3-step process. We automate all of it and make sure there are no human errors. And all these things can be actually tried out on our digital sandbox as well. And we believe that mitigates a lot of your risk.